Hello and welcome to the EV Life podcast. I'm your host, Crystal Maharaj, and I'm joined as always by
Allison Bench, the producer of the EV Life podcast.
So we have, I feel like we say this every time, but I do genuinely feel like all of our interviews are very interesting.
Mm-hmm. Yeah, we always introduce our interviews as being very interesting, but I think they are all very interesting. And today we have such a great interview to share with you. And we're focusing on EV range today.
Yes. So I speak to Greg Brannon, who is the Director of Automotive Engineering and Industry Relations at AAA. So our American version of AMA.
So AAA conducts its own testing of electric vehicle range. Yeah. And it's they recently, like within the last couple of years, released some information where their testing results had some discrepancies between what the manufacturers are releasing.
Yeah.
So that is...
It might not be a shock to listeners, I don't know. But yeah, they found some pretty interesting discrepancies between their own testing and the range estimates that were provided by auto manufacturers. And so he shares a little bit about those studies, how they even do range testing, which I wasn't really sure of. I kind of assumed they went out on the road and
drove it around. Yeah, no, but it turns out there's a very specific way these cars are tested. There's a very
scientific way that they do these range testing. And he shares what are some flaws with range testing and why there are discrepancies between what the manufacturer might provide and what their testing results yield.
Yeah, and I think we chat a little bit about they do test in different temperatures as well, which obviously
that's very important for us here in Alberta.
Yes, of interest to Albertans. So I think even though we're speaking to AAA in the US, there's so much relevant information to our members here up in Alberta.
So here's our interview with Greg Brannon. Again, he's the Director of Automotive Engineering and Industry Relations over at AAA. And here is our conversation on EV range testing. Hi, Greg. Thank you for joining me today on the podcast.
Yeah, thanks for having me, Crystal.
So I want to talk to you about some discrepancies that AAA found between EV range estimates provided by auto manufacturers and your own testing. So can you tell us a little bit about why it was important to do your own testing, and what were some of those discrepancies that you found?
Sure. So AAA in CAA, I'm sure to a good extent, is, we really started as advocacy organizations back when we were advocating for equal rights of motor cars among horses and buggies. And over the years, that hasn't really changed too much. At our core, we're still an advocacy organization. And so a lot of the work that our automotive engineering team does is focused on things that will make motoring better for the consumer, and for our 63 million members in North America, or I guess almost 64 now.
Yeah.
So we've conducted research for about the last 10 years now. My team has taken on dozens and dozens of projects, everything from the right type of fuel to put in your car to fuel economy ratings, and with EVs really coming on strong on the scene, we wanted to take a good look at electric vehicles and the range around electric vehicles. And so this issue started a while ago for us whenever we were doing some work on the temperature, the impact of temperature, which on electric vehicle range, which is something that I know that you in Alberta are very familiar with.
Yeah, it's a question we get often, right? When we talk to people about EVs, it's how does the temperature affect the range?
Yeah, well, we scientifically know the answer to that question. And at 20 degrees Fahrenheit, that's a little less than 0 Celsius, right? You'll find that on average, your EV will lose about 40% of its range in those temperatures. So it's pretty significant. And so during the course of that work, we uncovered some things that were pretty interesting. And of course, to get that baseline of the cold versus normal temperature, we had to do testing that was at normal temperature, which is about 75 degrees Fahrenheit, or very specifically 75 degrees Fahrenheit in a climate controlled dynamometer, which is like a treadmill for a car.
Right. And so that's right around, just for our listeners, about 24 degrees Celsius.
Right, very comfortable, and that's that's the temperature that most of us like to, as humans, well, we prefer the temperature, and so most of our aircon is sort of pointed around that, right? And funny enough, EVs like the same temperature, and that's when their batteries are happiest from a chemical standpoint. And so, anyways, during that research, we had to test and basically mirror the EPA standards to get our baseline before we put the vehicles in hot and cold chambers. And during that, we found that some of the vehicles we tested were pretty close to the EPA stated range of that vehicle. And some others were not so close at all. And in fact, we found some discrepancies that were nearing 20% difference between the advertised range, or the range that's claimed on the window sticker and certified by the EPA, and what we got. And so we dug into it a little bit further, and indeed we continued to find that trend. And so it's been kind of a journey over the last few years that we've embarked on to hold the Environmental Protection Agency accountable for the range that's stated on the vehicles. But it's definitely a challenging topic, and but we feel like we're right here at the dawn of the modern electric vehicle age, and it's very important to get this done right now.
That's interesting because we've heard from a lot of people, of course, here in Alberta, we have extreme cold temperatures, and we have heard from a lot of owners that, of course, you do lose quite a bit of range during those extreme cold bursts. But this is kind of the first time that I'm hearing in ideal temperatures, the range is different. But of course, you did testing, and most people aren't testing their EVs to see, how much range they're getting out of it. So this is interesting. And as a result of those studies, did AAA try reaching out to the auto manufacturers to kind of find out why there was that discrepancy?
We did, and we partnered closely with the Environmental Protection Agency here in the States, which is the organization that oversees the testing and all of the procedures and regulations related to this. And in fact, they worked with us, and we identified an issue that's sort of right in the open. And it's an opportunity, a loophole for automakers to jump through or to push the whole car through if they try really hard. And it's a little bit wonky. I'll try to explain it in a way that's easy to understand. So if you think about the way that a dyno works, this is the treadmill for the car, right? Mm-hmm. You've probably used a treadmill yourself, right? You know how you can sort of change the speed on that treadmill, or you can raise the incline, make it more difficult or less difficult.
Right.
A dyno basically works the same way. You have to tell it the sort of the drag of the vehicle that you're putting on it. So let's say you have a Corvette on the dyno, very small vehicle with very low wind resistance, right? Mm-hmm. And has a lot of horsepower, but probably does all sorts of trick things to reduce the drag as much as possible. That's going to have a very different profile than, let's say, if you put a box truck on the dyno, right? Something that is shaped like a brick and not very efficient and all of that. And so you have to tell the dyno what it's testing, because otherwise it doesn't know, right?
Okay.
Does that make sense?
That does make sense, yeah.
So to create those coefficients, they're called, that you input into the dyno, you basically take a vehicle instrumented with a bunch of data logging, high-tech, high-precision GPS equipment and wind speed indicators and all of these instruments, and you put it on a very, very flat, smooth track and bring it up to about 80 miles an hour, and then shift it into neutral and coast it down till 10 miles an hour. And you do that a number of times in different directions and everything. And then the average of those basically gives you that coefficient, because that assumes all of the aerodynamic and mechanical drag and everything associated with that car. So the box truck's not going to coast as far as the Corvette.
Right.
That's the simple way to think of it, right?
Yeah.
So the automakers, as you can imagine, is a very complicated and expensive process to carry out.
Right.
Because you have to rent a facility and then you have to have all the equipment and everything. And so the Environmental Protection Agency and everyone else basically allows the manufacturers, the auto manufacturers, to provide their own coefficients for the coast down of vehicles.
Mm-hmm.
And so everyone is just basically taking what the automaker provides for that number and plugging it in. And generally, if you plug that number in, you're going to get pretty close to what the range is that's on the window sticker.
I see.
The difference is, if you go do your own testing, you might find that maybe that coast down number might be a little bit different than what the automaker is providing.
Right. Okay, interesting. So is this kind of like the biggest flaw with range testing, is that number can really vary depending on who's doing the testing?
Yeah, right. And it's definitely one of the bigger issues with it. And, it's imperfect, and, there is some wiggle room, and the numbers, do allow for some wiggle room in there, but generally it's kind of odd that whenever we test them, they all kind of end up on one side of the curve.
You kind of mentioned that there were some vehicles that were very close to the range estimates that the manufacturers provided. Can you share which vehicles those were?
Well, I will tell you, since we published this study and since we have been down the path with the EPA, and they didn't really take a lot of action on the topic. They're pretty private in terms of what they are and aren't going to commit to. Mm-hmm. So we kept pushing it, and there's CNBC did a really good job covering this story a while ago, because we had been pushing them to pay a little bit more attention, and they actually talked with many of the people that we work with to do the research. And so I'd encourage your listeners to take a look at that story, and it kind of lays it out.
Are you aware of similar issues when it comes to range estimates for ICE vehicles?
Yes. The same issue exists on ICE vehicles, but some of the procedures are a little bit tighter for an ICE vehicle than they are for an EV. Yes, there are some of those issues, but there's more people looking on the ICE side than there are on the EV side. Quite honestly, the only thing that the EV range not being accurate is doing is hurting the consumer. It doesn't hurt the environment, or negligibly, right? Okay. And so there's not as much focus on fixing that issue, which is the reason we've been really pushing it with the environmental agency.
Okay. And so you mentioned that you did testing to get the baseline in kind of like ideal conditions. And then did you also do testing in extreme heat and extreme cold temperatures?
We did. We did in that original project. I think it was back in 2018 now. We tested both at 20 degrees Fahrenheit, and then we also tested at 95 degrees Fahrenheit. And of course, the impact is worse in the cold temperatures, as I mentioned, about 40% reduction at 20 degrees. But at 95 degrees, there's also some detriment, because the vehicle is trying to cool the battery as well. And so there's about a 15 to 20% reduction at 95 degrees as well, 15%, I believe.
I'm curious to know if you're aware of customers reaching out saying, hey, I'm not getting the full range of my vehicle. And has AAA heard from customers who are, concerned that they're not getting the full range out of their EVs?
It's interesting, because we're still in the early days, and many of the people that are buying EVs today are really enamored with the technology. They haven't hit mass market yet, right? So many of those customers are willing and understand that they are early adopters, and they're getting things that probably aren't fully sorted out, but that's okay. They're willing to take that risk because they're interested in the latest and greatest technology. So we haven't heard an outcry from consumers about this. I think, one, for that reason, and two, because it really takes some planning, and it's very difficult to run an electric vehicle out of charge completely unless you happen to have a fleet of tow trucks, which of course we do. Right. So because the EVs give you great warning prior to running out.
Yeah. And because, it's interesting that you point that out, because we've spoken to several EV owners here in Alberta, and your range testing was around, for the extreme cold, around, I want to say, -6 degrees Celsius. And we can get down, a typical winter will be in the minus 20s to minus 30s, which is, I think, around minus 20 Fahrenheit. So even extreme. And, people have said that they definitely lose a lot of range during the winters, but for city driving, it just hasn't been an issue because there's enough to get them to work, and then they can top up and, continue with their daily driving without being affected. It's very interesting for sure, and it'll be interesting to hear what consumers have to say as more people purchase EVs.
I think you're right, and it really depends on the use case, right? And we do a lot of work in this space around how people drive and distances. And in the U.S., the average consumer drives about 30 miles a day. In which case, a 15 or what is it now, probably 12-year-old Nissan Leaf with a range of 90 miles would be fine, right? As long as you have a place to charge it at home and you never tried to take it anywhere besides back and forth to work. But I don't know about you. Occasionally I do like to go on vacation or, run over to the town next to me. And so that's really where we're at with it. I believe that we're going to see more and more outcries related to this as it becomes more mass market and people see the opportunity to get into an EV, but then learn some of these challenges. I think it is going to be a barrier to growth, and that's why we were so adamant that the EPA needs to address this issue, and we need to get accurate ranges on the vehicle so people can know what to expect. And of course, the other piece of this too is that electric vehicles, whenever they provide a range number, they do not give, like we're used to, a city and highway number.
Okay, yeah.
Right? And so the interesting thing about EVs, of course, one of the many, is that they get much better range in town because they can benefit from regenerative braking. They do not do as good as on the highway, and that's the opposite of what we have grown to know.
Yeah, it definitely seems like even for the manufacturers, it would be, within their best interest to give accurate range estimates, especially for people living in those kind of extreme temperature zones. So, for consumers who are looking to purchase an EV, how would they go about trying to get the most accurate range estimate on a vehicle that they're considering?
I think there's a couple of things to do. There's an MPGE number that is provided with the vehicle, and that does break down highway and city with that MPGE, but it's a very difficult concept to understand, MPGE. It's basically the equivalent of energy that a gallon of gasoline has in it. And so it gives you a number and says that if this is a gallon of gas, this is the number of miles that this car would be able to go. And of course, electricity and gas are very different things, but they both have energy. Right. And so it's kind of a funky calculation, but it does give you some idea. And if you look at the city and the highway numbers, you'll see that there is a big difference between those two. And so someone thinking about buying an EV, I think you really need to understand your normal use case. We publish an annual driving cost study. I believe CAA does one as well. And the thing I always remind people whenever they're looking at the numbers there and shopping for a vehicle is to buy a car for the 95% of the driving that you do.
Right.
Because, and then rent one for the other 5%.
Yeah.
Because you're going to end up saving yourselves a lot of money. Don't buy a pickup truck just because you like pickup trucks, or you might get a bag of mulch at one time in spring. Because you're going to be paying $1.09 a mile. And the same will go true with an EV. You have to look at what your 95% is, and then rent a vehicle for the other 5%, or keep an ICE vehicle in the household, and you'll be better off in the long term.
Well, thank you so much for that. Last question for you is just how is AAA getting this information to your members? And also, are there plans to continue range testing for EVs and advocacy work on this?
Yeah, absolutely. And so we do it in we get the information to our members in a few different ways, both through sources like this, where we're talking to great people at one of the many AAA clubs, and you're able to get it out to membership that way. And we also work with national media outlets and local media outlets to share the stories in those ways. And then we use the leverage of the media then, of course, to prompt to prompt changes in regulation, because they know if AAA is doing it, that it's quality, unbiased research, and that the regulators have to pay up attention, because we bring with us some mass of members and a recognized household name that allows us to apply that pressure. So that's how we're getting the word out on this subject, and we're really happy to do it. And coming up, we're continuing some work. We're just planning for 2024 now. We've got several projects focused on electric vehicles, including a couple on tires. Because it turns out that electric vehicles are pretty hard on tires.
Yeah.
And we're going to try to quantify that.
Interesting. Well, it seems like you all are doing really important and great work, and I appreciate you taking some time to come on and share that information with me and our members.
Absolutely. It's my pleasure. And thanks for having me, and I hope everybody stays safe and stays warm up there.
Thank you so much. Thank you so much for listening to another episode of the EV Life podcast. Make sure that you're subscribed wherever you're listening so you never miss an episode. And if you'd like to connect with myself and Allison on any of the topics that we cover, make sure that you download the AMA mobile app and you join our EV Life group. We'd be so happy to connect with you. And we'll talk to you in our next episode.